Okay, so let's continue from there. So we were able to give feedback based on the selection made by the student. Now let's add something else. We just delete this screen. Meanwhile, somebody please think about a question which is a valid question and can be used or can be asked in using Desmos, interactive and both. Meanwhile, I'm just creating very basic question about straight lines. I'm going to add a graphical node here. So here is the graph. And here I'm going to enter the equation of line. Let's say y equals to 3 plus x. And you want to show, we can hide the grid actually, so that student will definitely figure out based on the logics, not just by looking at the grid. So we can have a point here, let's say 2, 5, right? Because it will lie on the line. And I'm not going to label it because that will be my question. So I'm going to ask my student to enter the value of, let's say we will show one value only, and then we will ask what is the value for that particular. We'll ask the y value of dot, and which we have already 5, right? So done. I'm going to add a note where I'm going to write the question. What is the value of? Meanwhile, guys, you can also think of another question so that I can give you more realistic thing in terms of coding and assessment part. Let's say, what is the value of y component of the blue point on the line, on the given line? Just using few words to ask my question. Now, if I see the preview, there is nothing. Student cannot answer anywhere. Look, this will also, I will help you how you can avoid, because student can click on it. See, if it is a classroom activity, it should be, right? So that student can interact with the graph. But if it is an assessment activity and you want to disable this thing, look, if I just put anywhere on the line, right, the points are visible. So they will just see the point and enter the answer, right? We can avoid it. What we have to do, again, go to the computation part. And here we have, this is the computation layer document where you can go and just check if you don't remember those things. There are so many things. Animations, point, label, trace. Look, this is the tracing part. Tracing the curve. So tracing part, we want to hide it. Tracing, disabled, false. Tracing, false. So now student will not able to trace the graph. Whatever you do, student will not able to see the point. So student has to figure out what is the y value. Let's say y value is visible here, but x value is not visible. So you can just change your question or go to the graph and change your grid or something, whatever you want. It's up to you only. So let me just change the x component now. Okay. If you want to show the line, that is also perfectly fine. You can also show, let's say the equation is y equals to x plus or 3 plus xi, x plus. You can also show the equation here. There is no issue. Look, so you are asking the x component if of the blue point on the given line, right? So now student cannot click on the graph to see the answer, but he just to see if y is 5, what is x, right? So you can add different things here. How you are going to ask your student? Let me ask with the math input. Simple. Math input. So my student can just add 5. Oh, sorry. But nothing is happening. It's still a dot. student is not getting any response, or teacher is also not aware whether this answer is correct or not. So to do that, what you have to do, go to the either the computation layer of the graph or on this math input. Remember, always add a code where the student is interacting. Now, technically, student is not interacting on graph. Student is getting the information from the graph, but entering the answer in this component, which is called math input. So I just can label it math input. You can give any name so that we can actually keep these things unique. So I'm just using M input. Let's say math input. No problem. I'll go to the coding part and just write correct when it is correct. When this dot number, because it's a numerical value, right? Numerical value is simple. Go to preview. If you enter 2, if you enter 4, which is a wrong answer, you see the cross. But if you enter 2, it is a correct answer, but teacher is not able to recognize it. So what is the mistake here? The mistake is nothing, because there are two components, graph and math input. So just go there in the graph, because student is not interacting here. Write down read only. Read only true. Sorry. Read only true, because this is only to read. It's nothing to enter, because in the previous screen we were dealing with the dragging graphs. But here the information is only to see. So yeah, you can just say 2 here. Look, it's tick, means on the dashboard, teacher will immediately see the student has entered the correct answer. Again, as I said, if you want to ask for the working steps or the full solution, you can add other components as well, right? And usually what I do, I use table for working steps. I just delete one part from here, right? Delete column. And here I always write working steps. And here you can add 3-4 columns. Make sure the student is not interacting with this for validation of the answer. Do the read only true for this as well. You're all set to go. Look. So answer is here, but working steps will be here. So maybe student will write, okay, 5 equals to x plus 3, and then 5 minus 3 equals to x, which is 2 equals to x. So student will enter here, 2, and submit. Look, it's correct. And feedback part, I have already told you what you have to do to give feedback. You have to add a note component, arrange it where you want to give feedback, and then whatever you want to show, let me just put it below that. And see, math input is the name of that, where the answer is correct. So go to this note, and what you can do, you can go back to the previous screen where we added that component and copy that. Simple. Copy this. Sorry, not this one. It was the other one. This is the advanced one. I'll show you the advanced one later on. So this is the simple one. Copy this. Go and paste in your new activity in the node component. You remember, this is the node part. Go to the computation layer, paste. What you have to change, this one only. This is math input, and this is not the number. It was the numerical value equals to, I think, 2. And we are not checking with 2 components, so you can delete this. Simple. That's how you reuse the things. What I did, math input, which is the name of that component where student is entering the answer, right? And I'm just giving feedback here. That's it. Look, the feedback text is already there, and it's optional. Student can write steps or not. That you can also mention at the top. Look, I'll enter 2. I'll get the feedback correct. Otherwise, I will not add. If you want to give the wrong answer, Then also possible that you want to show that it is wrong answer. For that, just change one line. In the otherwise, you can say wrong, right? That's it. Or try again. That's what I like. I don't say wrong. I'll say try again. Or you can be more specific. So let's say I'm entering whatever I want here because these things are not important for me. This is just to have some value in that. Look, it says try again. If I enter wrong answer, it will show try again. If I enter correct answer, it will show correct. You can write correct, go to next question, go to next slide. So look, we have added different things and that's how you can interact. Now in the next one, what I'm going to do, preview, make a copy of this and go to the next page, paste it, Control V. Now I'm going to ask students to enter the line. So I'm going to just say f of x. If don't add slider here, right? Because otherwise it will take the values of that. So delete this slider. You can have one more point. Let's say we want to ask a student to enter the equation passing through these 2 points. So one, let's say 3 comma, okay, 4 comma 7, fine. Right, you want to label it? Yes, you can label it, show them like this. Now change the wording of this, right? Delete it, write the equation of a line passes through, sorry if my spellings are wrong, passes through these 2 points, 2, 5. And next time I'll tell you one more trick where every student of your class will receive unique question on the same concept. Okay, so I have changed the equation. Now in my math input, in the coding part, what I have to do, technically it was the numerical value, right? Let's not do the correctness now, but what we need here, what I want, as soon as student will see these points, student should enter the expression here. Let's say x plus 3. They should see the line. Even if they enter the wrong answer, they should see the line. Okay. Now for that reason, I will go here and just remember this math input because this is what I'm going to use. Now tracing, you can make it read only, that's fine. But what I have to do, function f, because that is a function. So what I have to do, use this one, simple function. Where is the simple function? Simple function is the command to enter the equations. Now where I want to enter the equation, use the double quotation mark and use a dollar sign. And here you can say, okay, maybe let's do that. Math input dot latex. That's the way how you can, this is the, let me just zoom in. I know you guys will see this is complex thing. See, function is f, because to create a line, you have to relate y and x values. By entering a constant value, you won't be able to see the graph. So this is the way how you enter the equations in x and y. So it's called function. Then the name was f. We have already defined in the graphical part. Now what it is doing, simple function command, where we are entering math input dot latex. We are connecting 2 parts. You enter something in the math input, but you see the equation in the graph. That's what we are doing. Preview. Let me show you. We are not checking right or wrong here. Look, as soon as you type x, you see the line. As is x plus 2, x plus 3, right? Now, this is the validation part is not done yet. What I have done only connected 2 things. Let me show you this thing again. Then we'll come back to this and show you how you can validate these two. What I have done, add math input, sorry, add a graph first and a math input. Define them, that would be great. So I'm writing math input on slide number 6. I'm just using that number for reference. And here, go to the graph part and just write f of x and do nothing here. Don't add slider. What information you want to show? For that, please enter those 2 points. Let's say 2 and 4. We can show the label if you want. And next one could be 6 and 8. You can change the color if you want. Go to the setting, change the color. Which color you want? Black. Okay, black. Fine. You drag it down so that students can see the correct values and then they can figure out what they have to enter. So I'm done. And now let's connect them. If I show you without connecting, nothing is going to happen. You write x plus 3, nothing is going to happen on the graph part. Now for that, we have to reconnect. So go to the computation layer and use the graphical thing which we says function. What was the function? F. You can also define gx. There is no problem. Simple function. Where is a simple function? Math input 6 dot latex. Done. Type x. Look, this time it was easy. Previously I could maybe confused you guys. Let me show you again what I did. Okay, let's change the function to g so that you guys can feel it differently. Gx. Done. Go to the computation layer. Function f is not there now. Add g. Simple function, and inside the brackets you just add where you want to add the equation. So math input 6 is my enter value component. Dot latex I'm saying because it is a function in x and y. So latex, what we use to convert anything in math expressions or equations. Look at this. No matter you are entering x only, you can write x square. Look, you will get the parabola. So every expression will be taken care. You can add sin x. Anything you can add using this simple trick. Now, if you want to validate this, then of course there are different ways how you can validate. Now to validate, let me first so shall we validate this part only or the previous part? Let's validate this only, right? So the line, sorry, we forgot to write the equation for that. Let me just write this. Okay, let's do that. I'm just making a copy of the question, writing here. Let's change the point 2, 4, 6, 8. It's super easy. If you know the trick, you can even do the quadratic, cubic, trigonometric, anything. Are we looking for straight? Yeah, like us. No, it's not the specific thing. I just thought of a question and was showing you that how we can use this thing for straight lines. So if you enter x plus 3 or x plus 2, x plus 2 is the correct answer. Sorry, even if you want to write y equals, that will also work. No matter what you type f of x, no issues. Because it will only take the value of x. Look, if I enter t, it won't consider, right? Nothing, because we have defined in terms of x, and by default it is in x. So no matter you're writing y or f of x or simply x plus 2. Let's do the validation part. How to? check the correctness, right? Now, this was the function G, right? And let me make it readable only, readable true. Now go to the math input part where a student is entering the answer. And here, write down how you want to check. Correct. Math input 6 dot latex. Look, if you type, let me show you some I have seen people doing this. If you just enter x plus 2, right? X plus 2 math input dot latex equals to x plus 2. You tried. This is the simple way. This is the simple way how you can add. What I have done, very simple thing. Math input 6 dot latex, the one same over there, and enter the equation. But what is the difference here? If I write x plus 2, this is correct. For teacher, it is correct. For student, if they are entering y equals, or by mistake they are entering 2 plus x, it will not work because it is matching exactly as the text. Whenever you are using double quotation, it means we are validating the equations with the text. And if you want to avoid this, erase it, better you do the other things. Let me tell you what we have to do. Just define the function, right?
Yes.
Okay, maybe we can just do it another way. F equals to, I'm just defining F, that is a solution for this. Simple function, this dot latex. That's it. Okay, let's not do even that. Delete this. Let me tell you the simplest way. Correct. Oh, correct. Simple function is dot latex. Now it will convert it into equation. Use dot. Evaluate add. Use some values against which you want to check. I'm just using the same which I have used. 2 equals to 6. I think we are using two values now. We'll use both. I'll just repeat the whole thing and we'll change x and y values. The one I have entered in the bracket, that is x value. You can add anything. It should just match with the equation. Even if I write 12 and 14, because they will make sure my equation is correct. Now you'll see that this dashboard preview will be correct. If I enter x plus 2, correct. Even if I enter 2 plus x, without even x or y, nothing, no problem. Because now this part is actually taking care of the values. This is x value, this is the y value. So for every equation where these equations are satisfied, for those equations, your Desmos will show you that it is correct. Right? So let me just put on hold this now and I'll take your question.